In 12.1 and 12.2, we learned how to count large items or count groups and count sets of items. And it was important to learn how to count things first, because now as we move into probability, those countings help us find out the totals. So in looking at 12.3, it says an introduction of probability. The main takeaways that we need to know is a notation for probability. Probability is written with a P. There are parentheses that are written, and within it, it is giving you what you are looking for. Now, as we find probability, probability is always going to be a fraction. It's going to be an amount or the ways that we can make what we are looking for answer the question with a yes. And the bottom is going to be the total ways that this event could possibly happen. Okay, and so since it is an amount out of a whole, it looks like a fraction in the same way that we would say if I had half a pizza, I had 1 out of 2 slices. So when we have a fraction, every single fraction, the bottom number tells us what it takes to make the whole process or the whole amount. The top tells us what we have. So we've always been looking at a fraction of what I have out of what I need to make a whole amount. So a probability works the same way. We are looking for a portion of it out of the whole, and the portion that we are looking has to make what we're looking for positive. It has to make it answer with a yes, is the way that I like to describe that. So that means we are looking for 2 different numbers. We are looking for a top number and we're looking for a bottom number. And to find the bottom number, since it is the total, we often need to either use permutations or combinations to find that total, or sometimes we just use our fundamental counting method to find the total on the bottom. Sometimes they give us what the total on the bottom will be. So that's how we can tie in 12.1 and 12.2 into 12.3. So important things that we need to know about probability. Probability will always be between the number 0 and 1. 0 is 0% chance. 1 is 100% chance. Everything in the middle will either be a decimal or will be written, or it could be a fraction. So a fraction, decimal, or written as a percent. Because it is less than 1, we can always write it as a percent as well. So you'll see that I often interchange or will write both of it along with there. Now, when it comes to probability, there's different ways that we can find it. There is theoretical. So often we hear, well, in theory, that would work. So theory means perfect case. So we're looking at perfect case scenario. Everything has an equal chance. Then often you have experimental. If you don't exactly know details, or maybe you gather data from a chart, or from sales that you have had, or from a survey that was done, then every portion of it is not going to be equally laid out. And so that's going to fall into experimental probability. Now, when we are dealing with theoretical probability, there are things that we will look towards in 12.4 and 12.5, that as we begin doing more than one probability at a time, we will have ors or ands. For 12.3, we are looking at single events. So this is one single event, one roll of a die, one draw of a card, one playing of a song, so on and so forth for that. So when we are looking at single events, a lot of what we have to do is just decipher what they are asking us to find in it. The thing that we do know, since probability works from 0 to 1, is that whatever we do have plus whatever we don't have will always add up to be 100%. So if I do, say we're looking at a pizza and it's divided up into 8 slices here. If I do have 3 of the slices, that means I don't have 5 of the slices. It would always have to equal 1. If I do have 2 of the slices, then that would mean I don't have 6 of the slices. So with probability, we can always say that the probability of what we do have plus the probability of what we don't have. And that is written with an A with a little accent mark on it. We've seen this accent mark often in our mathematics. We've seen it for inverse functions. We've seen it with inverse matrices. It just means it's the opposite. And so if this is how much we do have, then that's how much we don't have. And these amounts always have to add up to be 1. So those are a couple of the rules that we will be working with in our probability here in 12.3. Okay, so if we were going to be looking at a couple of the homework problems, I'm going to start with the first part that says 12 through 17. It says choosing numbers, you have an equally likely chance. So whenever it gives you those words, equally likely, that means they are telling you in advance that we have a theoretical probability, that each one has the same chance. And so when we look at it, we can assume that all of them would have the same chance. Probability can be said as what is your chance of finding something. It can be the percent out of another thing. So get used to all the different terms that are being used for it. So number 12 says the probability, it says you have an equally likely chance of choosing any integer from 1 through 20. So say you have numbers in a hat and you have the numbers 1 through 20. It says find the probability of the given event. So the probability of choosing an odd number. So we know we have to, on the top, we have to find the ways that we can make this question, how can I choose an odd number? We have to make that be true, or like I said, answer the question yes. On the bottom are the total ways that you could draw a number. Because we are looking at drawing numbers. You have an equally likely chance of choosing an integer. So numbers in a hat. So how many different ways could we pick numbers out of that hat if I'm picking one? Well, I have 20 different options. I have 1 to 20. So the total different number of different ways that I could pick a number would be 20. Now, how many ways do I have of choosing an odd number? That would be if I picked a 1, 3, 5, 7, 9, 11, 13, 15, 17, or 19. Those are all the ways that I could pick an odd number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ways that it could be an odd number. So if I say the probability of drawing an odd number when I have these 20 numbers in a hat is I have 10 ways that I can make that true, that I can pick an odd number out of 20 total ways. So my probability is 1/2, 0.5, or 50% for that. Now, if number 16 asks, what is the probability that you draw a multiple of 3? So if we're looking at a multiple of 3, we know we still have our numbers 1 through 20. So I have 20 ways that I can pick a number. What ways can I make a multiple of 3 true? Well, I could have 3, 6, 9, 12, 15, and 18. So there are 1, 2, 3, 4, 5, 6 ways that I can make that true. So I'm going to say 6 out of 20. That can be reduced down to 3 out of 10, which would be 0.3 or 30% chance of me picking out a number that is a multiple of 3. Now, if I am choosing cards, So 18 through 23 talks about cards. There are things that we need to know about cards. First, cards have 52 total cards. There are 4 suits, 2 red, 2 black. There are 13 cards in each suit, and there are 3 face cards in each suit. Okay, so it says, what is the probability of drawing this specific given card? So remember, we've got this deck of cards. We've got all these cards. We're picking just one. We're picking one card out of it. So the probability of getting the Ace of Hearts. So first, I'm going to look at the total. If I have a whole deck of cards on a table, how many different ways can I pick one card? I can pick 52. There are 52 different ways that I can pick one single card. So then on the top, I ask, how many ways can I pick an Ace of Hearts? So how many options do I have of getting this one card? Well, there is only one Ace of Hearts. So it would be 1 out of 52. We would divide that and get 0.0192. If we move that, that'd be 1.92% chance of drawing the Ace of Hearts out of a deck of cards. So if we look at number 20, we're looking at the probability of drawing a diamond. So again, I have all 52 cards on a table. They're all kind of scattered around. How many different ways could I draw one single card? We can draw it 52 different ways. So the bottom is always your total number of different ways. The top is how many ways can I make my probability be true? So I'm looking for this to be true. So how many ways can I draw a diamond? Well, there are 13 cards in each suit, so there's 13 diamonds. So it would be 13 out of 52, which is the same as 1/4, which is going to be 0.25, and that's going to give us a 25% chance of drawing a diamond. Okay. Now, if we look at 22, it says we want the probability of drawing a card other than 10. So other than 10. Now this one, we're going to use some logic with it. So if I draw a card other than a 10, I have this huge long list. Since there's 13 cards, that means I have 12 other options. That means we would need to find the probability of all of the options except for 10 and add them all together. Now, we are going to use that sweet little rule that we know that says what we do have plus what we don't have always has to equal 1. So instead of finding the probability of drawing a number other than 10, which means I have to find the probability of all 12 of these, let's instead find the probability of actually drawing a 10. So the probability of drawing a 10 means that I have 52 cards. How many ways can I draw a 10 out of 52 cards? Well, there's 4 suits. Each suit has a 10 in it. So there are 4 10s in there. I could draw a 4 of hearts, a 4 of diamonds, a 4 of spades, or a 4 of clubs and get a 10. And so that's going to, I don't know on my calculator. So this is going to give us a percent, but let's not deal with the percent first. So then when we find this, we're going to say this is the probability of drawing a 10, but they didn't ask me for that. They want the probability of not drawing a 10. So we're going to take 1 minus 4 over 52. So we're going to make this 52 over 52. And we're going to say I've got 48 over 52 is my probability of drawing a card other than 10. That gives us 0.923 or a 92.3% chance. Now, that's one way. We could think of it initially When you are back at the beginning without doing it in the inverse and say the probability of a card other than 10, knowing that we have 52 cards total, how many cards are not a 10? Well, there's 12 cards in each suit that are not a 10. So 12 times 4 gives us 48. There are 48 ways that I could draw a card that would not be a 10. It would be an other than a 10. These would make this statement true. And we get 48 of a 52. So 2 different ways to approach that problem. Now, in rolling a die, we know that a die, it has 6 sides on it. So the totals that we're going to have initially are 6 sides. For 24 through 29, they give you some experimental probability numbers there with the chart. So with a theoretical probability, we would say that for every single number, you're going to have a 1 out of a 6 chance because it's going to be an even amount every single time. They are actually giving you some numbers for you to find your experimental probability as well. Now, when you go down to geometry portion and you have the targets, I don't remember if those were assigned, but when it says the probability that the dart thrown at the square target will hit a given region. So now we're having to look at area. And the total area that we have is going to be the total area of the square. We know that our square is 24 inches. So our total in that case is going to be 24 times 24 is again going to give us the total area. So if they ask for the probability of the white area, my total is going to be the area of the square. Okay. Now, the way that I get the white area is I have to take the area of the square and I have to subtract out the area of the circle, the largest circle. And we know that the area of a circle is pi r squared. And so we would use these steps to find our probability there. So the main takeaway for probability is to look and make sure that you are answering that probability question as truth. Now, for number 37, they give you a Scrabble chart. And then they're asking, what is the probability that you will choose 3 vowels and 4 consonants? So you are picking 7 numbers, or 7 letters, sorry. So we're picking 7 letters that we have, and we're going to use our fundamental counting method here. They're asking specifically to be able to answer this question as a true statement. They want it to be 3 vowels and 4 consonants. Okay. So we could say it's a combination of a certain number of vowels taken 3 at a time and the combination of consonants taken 4 at a time. So you're going to have to count up how many vowels there are. So A, E, I, O, U, and it says count Y as a vowel. You'll need to add up the tiles, the number distribution of letters for A, E, I, O, U, and Y, and find out how many there are there. And then add up the other ones. And then what you will also find is that the total number of tiles is 100. So you have 100 tiles in the box or the bag that you can pick from. So when we have our vowels, when we are doing our vowels, when we draw the first vowel, I think it is, let's see if I can look at it real quick. Let's see what our numbers are. We have 44 vowels and 54 of the other. Okay. So we would have 44 would be the highest, then 43, then 42. That would give us our vowels. Our consonants, we have 56, then 55, 54, then 53. Okay. Now, there are duplicates because everyone knows that when you have your little Scrabble board and you have all your letter tiles on here, that you can arrange them however you would like, correct? So it doesn't change the vowels. They can be arranged in a different order. And since this is in a different order, it's a combination. So we've got a combination of 44 things taken 3 at a time. Here, again, the order doesn't matter. So we have a combination of 56 things taken 4 at a time. And these are all the ways that we can make this statement true. But for probability, we need to know the total. So that's the way to make the statement true. The bottom gives us the total ways of having 7 letters. Well, I had 100 choices for the first, 99 for the second, 98, 97, 96, because I can't pick a tile twice. It might be the same letter, but it won't be the same tile. So again, when these are all on our little Scrabble tile holder, it doesn't matter what order we put it in. So this is a combination of 100 tiles in a box, 100 things taken 7 at a time. So we have our probability set up. It looks a little bit more complicated, but we still on the top, we have the ways that we can make that statement true. And on the bottom, we have the total ways that we could get our entire set. So that's the wrap up for 12.3 as we introduce thinking about probability.